Okay, so on the previous page we went over all the different rules for exponents, and we have those rules so that we can simplify expressions involving exponents. And this list here gives us some of the steps that we should think about when we're simplifying with exponents. So for something to be considered simplified, there can't be parentheses anymore. And if it's a monomial, one term, then each variable or constant appears as the base at most once. So for example, if you had an x cubed and times x to the fifth, you would want to combine that as x to the eighth. And then each numerical expression, such as 5 squared, should be calculated out, and each numerical fraction should be simplified or reduced. So let's go ahead and run through a few examples using the rules that we had on the previous page. So simplify each of the following, and the first one, part A, we have x to the fourth raised to the ninth. So this is one power raised to another power, so we use the power to a power rule, which says to multiply. So this should be x to the 4 times 9, or x to the 36. Moving on to part B, here we have 1, 2, 3 factors inside of the parentheses, and it's all being raised to the third power. So this would be our product to a power rule that says when you have multiple factors inside being raised to a power, you need to distribute that power to each one of those factors. One of the things people forget a lot is that the 2 is a factor, its own factor, so the 2 gets raised to the third, just like the x squared and the x to the seventh would. So this would be 2 to the third, x squared to the third, and x to the seventh to the third. So 2 to the third we'd want to work out. That's 2 times 2 times 2, which would be 8. So that would be an 8. And then we have x squared to the third, that's power to a power, so that would be x to the sixth. And again, power to a power, so 7 times 3 would be x to the 21. And then these are both the same base, so we'd want to combine that, and when you have two things with the same base and you're multiplying, you add their exponents together. So this would be 8x to the 27, where that 27 comes from adding those two exponents. And I'm going to go ahead and box that answer, but I'm going to come back to this and I'm going to list it also as a B star. And I'm going to show you another way that that problem could have been done as well that might be a little faster or perhaps a little easier. So let me copy it again. 2x squared, x to the seventh, all raised to the third power. Instead of distributing right away, another option would be to work inside of parentheses first. Realize that we have these two with the same base and go ahead and combine them by adding their exponents. So that would be 2x to the ninth power. And we haven't done anything with the 3, so it would still be out there. And then we would raise each factor to that power, so we'd have 2 to the third, and x to the ninth to the third, and 2 to the third is 8, and x to the ninth to the third, we would multiply the one exponent with the other, and get x to the 27th, same answer as we got before. So those are both equally fine options. You could do either one. You could distribute first and then combine the like bases later, or you could combine the like bases right away and distribute the power of 3 later. Just really up to you. I wouldn't argue one over the other. Alright, let's look at part C. So 18y to the 10th over 24y to the 4th y to the 6th. This time I'm going to go ahead and take the tact of combining these two first. So I see the two different y's with the same base, so I'm going to simplify those. And while I do that, I happen to notice that the 18 and the 24 have a 6 in common. So I'm going to rewrite that 18 so I can see the 6. So 3 times 6, and then I have a y to the 10th. I'm going to make that 6 show up in the 24 also. That's 4 times 6. And then when I combine these two, they have the same base, so I add exponents, and I get y to the 4 plus 6, which would be to the 10th. So I'm going to cancel that 6 that I noticed a moment ago and revealed when I factored, so those can cancel off. And this wasn't necessarily the goal when I combine these two, but it turns out that it matches up with the numerator exactly. So I have 10 y's in the top and bottom. I can cancel those off, and all that's left is the 3/4. So kind of messy at the start, but just with a couple different steps of combining, a lot of stuff was able to be reduced away, and we got quickly down to that 3/4. Alright, let's go ahead and look at another example. This time we have a fraction to a power, or a quotient to a power. And on the previous page we did have a quotient to a power rule that said if that is the case, take your numerator and raise that to the power. Take your denominator, raise that to the power. And then now you have power to a power, so you multiply exponents, x to the 8 and y to the 20. Sometimes there's a temptation on people's part to look at the 8 and the 20 and see a 4 and decide to cancel that. But you have to remember there's not actually any 4's in the numerator. There's 8 x's. And there's no 4's in the denominators. There's 20 y's. So this 8 isn't a factor, so its factors, 4 and 2, are not factors of the numerator. The 8 is telling me how many factors of x I have. The 20 is telling me how many factors of y I have. So exponents cannot be reduced like we could reduce the 6's in the 18 and the 24. Alright, continuing on with some more examples of simplifying involving exponents. So here we have a fraction that's raised to a power, so we could use the quotient to a power rule and raise the numerator and denominator each to that power. But in the numerator we have 1, 2, 3 factors, and in the denominator we have 2 factors. And the product to a power rule says if we have 3 factors raised to a power, each of those gets individually raised to that power. So what I would usually do with this is apply both the quotient to a power and product to a power rule simultaneously and say that in a fraction like this made up of all multiplications, that the exponent gets distributed to every factor inside, so to the 5, to the x, to the y to the 4th, to the 7, to the y, or w cubed. So writing that out, going through each one at a time, I get the 5 squared, I get x squared, I have the y to the 4th squared, the 7 gets squared, the w to the 3rd gets squared. So again, every single factor inside of that parentheses gets that exponent distributed to it, and that is actually using both the quotient to a power and the product to a power rule simultaneously. And then I would just start simplifying. So 5 squared, 25, x squared is already simplified. Here we have a power to a power, so I'd multiply y to the 8th, and then just moving down doing the same steps in the denominator. 7 squared is 49, and power to a power here, so w to the 3rd raised to the 2nd would be w to the 3 times 2, or w to the 6th. And none of our bases are the same here. This is all 5's, this is all 7's, x's, y's, w's, nothing in common, so that would be as simplified as we could get there. We've removed parentheses, which is one of our requirements, and we've carried out the exponents on any numerical factors. When we look at part F, at first it looks similar, and you might think I'm going to take that 2 and distribute that to 1, 2, 3, 4, 5, 6 different factors. The important thing to see here is that the parentheses are only on the numerator, so that 2 only applies to the numerator. So I would distribute that 2 to each of the 3 factors there and get 4 squared, x to the 5 squared, y to the 8th squared, but that's where that distribution of the 2 ends because the bottom was not involved in that parenthesis. So I'm just going to copy the bottom. And I'm going to work out the top, and once I get that simplified, I'll deal with simplifying across the fraction bar. So the 4 squared is 16, power to a power, so we multiply x to the 10th, power to a power, so we multiply y to the 16th, and again the bottom I'm just copying, 8, x to the 8th, and y to the 9th. And then I want to simplify by removing any common factors, and I see an 8 in common here, so I'm going to show that. That's 2 times 8, and I have the 8 on the bottom, so I'll cancel those off in a minute. When I have the same base, you could use the subtraction rule. You could also think of it as if there's 10 x's up here, that means you could split that into 8 x's and 2 x's. And then on the bottom I would have 8 x's, and I'm revealing how many they have in common, and so I could just go ahead and cancel those off instead of thinking about the subtraction rule. I'll mention the subtraction rule would work as well, but this is kind of the way I think of it mentally usually. If I looked at this, I'd think these 9 y's are going to cancel 9 of those y's, and there'd be 7 left over. But just to show you that, y to the 16th has 9 y's like there is in the bottom, but there's still another 7 to make up that total of 16. and then I have those 9 y's in the bottom. So if I write it that way, then I can see all the different things I want to cancel: the 8ths, the x to the 8ths, the y to the 9ths, and then I can think about, alright, so what's left over? And I would have the 2. I'd have these 2 x's, or x squared, and these 7 y's, or y to the 7th. And everything in the denominator cancels, which means there's still a 1 there, but we don't consider a fraction to be simplified when we write it over 1, so I would just write it without that. And it's also very common for me, if I'm at this step right here, to just jump down here to that answer and not write out those common factors, but just think about them. So I might say 8 goes into 16 twice. These 8x's cancel 8 of the 10, and that would leave 2 left over. These 9 y's would cancel 9 of these, and that would leave 7 left over. So it is possible to do that in your head rather than writing it out. You decide what's more comfortable for you. And then you also could have used the subtraction rule: x to the 10 over x to the 8. You subtract exponents, so x to the 10 minus 8 is x squared. Y to the 16th over y to the 9th, we would do subtraction, so y to the 16 minus 9, which is 7. I don't like doing that purely as just a rule. I like to think about it. There's 16 y's up here. 9 of them will cancel with this, and that would leave 7 left over. That's a little bit more logical to me, and I prefer to think about it in that logical manner rather than just trying to execute a rule. Alright, one final example, and this one is an application, so let's go ahead and take a look at that. The weight, f of d, in ounces of a thick crust pizza with 3 toppings at Papa Del's is described by the equation f of d equals 0.41 times d squared, where d is the diameter in inches of the pizza. Estimate the weight of such a pizza with a diameter of 12 inches. So let me go ahead and copy the function down here. F of d equals 0.41 times d squared. And then let's think about what they're asking us for and what they're giving us. They want us to estimate the weight, and it says up here the weight is f of d. So we're trying to figure out the f part of this equation. And then they provide us with a diameter of 12 inches. So that would be d. It says here the diameter is d. So they want us to figure out the weight when d is 12. So they want us to figure out f of 12. And we would do that by plugging the 12 in. So 0.41 times 12 squared. And one way we could do that is do a little work in our head. If we take the 12 and square that, we would get 144. And then at this point, I would go ahead and just move over to the calculator. Let me bring that in and just do that multiplication. So 0.41 times 144 is 59.04. And in an application like this, we should always put units on our answer. So we have to think about what it was we were trying to find. We were trying to find the weight, and it says that the weight was measured in ounces. So this would be 59.04 ounces. And that would be our answer. I'm just going to go ahead and mention one other quick thing on this. Once you plug in the 12 into the function and you get to this point, it wouldn't bother me at all if you went to the calculator right then and jumped across to the answer. So let me just go ahead and show you what that would look like if you chose to do that. You do the 0.41 and then times 12 and then just raise that to the second power, and that'll take you straight over to your 59.04. Okay, that's it for this section.